Hello, my name is John Graves. In this podcast, I'm going to be talking about the teacher conceptual change relative to asking questions in science, which is the first half of the science and engineering practice of asking questions in science and defining problems in engineering. I will deal with the defining problems in engineering section in a separate podcast. If you have not had a chance to look at the podcast that introduces teacher conceptual change and the next generation science standards, I highly encourage you to do that. A link to that podcast is listed in the video description below. The teacher conceptual change relative to the next generation science standards is predicated on a conceptual change cycle or a conceptual change model. Also, a link to this diagram on conceptual change is listed in the video description below. You will notice that at the bottom right-hand side of many of the slides throughout each podcast, I will delineate which step of the conceptual change cycle we are on as I'm going through the podcast. So we're going to start off with talking about building awareness. I would like you to get your framework for K-12 science education book if you have that. If you need to pause the video and get a PDF version of that, there's a link to that also in the video description below. Open to Asking Questions in Science and read through that brief section of how they describe asking questions in science in the framework book. Once you've done that, I'd like to help you unpack what the framework is asking us to do by first of all identifying the verbs that you just read through that material. What are the verbs that are listed there? In other words, what are students expected to do? You could make a list of those words to give you an idea of what students are actually expected to do in this practice of asking questions in science. Now that we've taken a look at what students are expected to do, let's identify the nouns that you just read about in that description and figure out what students are expected to produce as a result of having some mastery of the science and engineering practice of asking questions in science. Now, to help you with your conceptual understanding of this practice, I'm going to help expose your beliefs by engaging you in asking these questions of yourself. This self-reflection piece is so important as we work through this conceptual understanding of next generation science standards. So now that you've read that bit in the framework, what are your current beliefs about this practice? Ask yourself, in what ways are you using this practice in your classroom? What challenges do you see to using the practice of asking questions in science with your students? If you have the ability to carry on a conversation with a colleague, I highly encourage you to do this because that will really deepen your understanding of this practice. Also, think about types of questions that students can ask when they're working in this practice of asking questions. When I think about asking questions, there's certainly myriads of questions that are out there, but generally speaking in science, questions seem to fall into two categories. They are either testable questions or they are researchable questions. And if that's new to you, you might want to spend a little bit of time thinking through this notion of what's testable and what's researchable, because students will need to have that understanding as well. Another thing that you might keep in mind is most of us were introduced to the Bloom's taxonomy at some point in our teacher preparation, and I would encourage you, as you are thinking about asking questions, that you think about them also in terms of Bloom's taxonomy, because a question in the bottom layer of remembering is very different than a question that's asked in the application stage, or very different than questions asked in either evaluating or creating. So if you're not familiar with Bloom's, you might want to take a look at that a little bit deeper and see how you can begin to ask questions and help your students ask questions that are at various stages along Bloom's taxonomy. One of the ways that we can help students engage in asking questions, and I can help you engage in asking questions as you work through this conceptual understanding, is to present a phenomena to you around which you can ask some questions. So I'm simply going to show you this rope tube, and you'll see that it's a tube and it has 4 pieces of rope sticking out of it. And you'll notice that the rope is long right here, but what's interesting is if I pull on the rope on the other side, the rope is obviously connected at the top. As I'm doing this, I encourage you to ask questions, so you may need to pause the video and write some questions down. Okay, so back to this. We've got the rope connected at the top. We also find out that the rope is connected at the bottom. Wow, that's pretty impressive. Okay, so single rope across the bottom perhaps. Well, what's really cool too is the rope is actually connected sideways, so I can pull on this one, pull sideways. Well, we know that the top rope's connected, so I can pull here, and we find out that the other side's also connected. It's one rope, and then it even works diagonally. All right? So I'm using this phenomena to engage you in asking questions. So hopefully you can list a whole bunch of questions that you've just generated as a result of watching that phenomenon. So as you went through this and you think again about researchable questions, about testable questions, about questions along the hierarchy of Bloom's taxonomy, what ways were you challenged in your beliefs about the practice of asking questions simply by seeing a phenomena such as this? What are ways that you can foster the understanding of asking questions with your students? And what are some ways that you can make this practice a part of every learner's repertoire? So these are questions that you can ask yourself. Again, you can engage these questions with a colleague. This helps you in the conceptual change cycle step of reinterpreting your belief. The rope tube activity that I shared came from the Toolkit for Teacher Conceptual Change that is linked in the video description below. In addition to the rope tube activity, there are 2 other activities that are specific to helping you work through the conceptual understanding around asking questions. I highly encourage you to take some time and work through those other activities. I also encourage you to refer back often to the conceptual change cycle model. Evaluate yourself. Where are you on this conceptual change cycle relative to each of the practices that you encounter? What you'll find is that you are more comfortable with one practice than another. So it's a great check to see where you are in your understanding conceptually of each of the science and engineering practices. In addition to the conceptual change model, there's also an assessment that's linked below for each of the science and engineering practices. And again, this is a great way to self-assess where you are on your understanding of each science and engineering practice and how you're utilizing these in your classroom. Well, I hope this material has been helpful, and I hope you spend some time with the resources that are linked in the video description below. Thank you.